Okay, question number 5. A space of a mass 1,500 kg is traveling from Earth to planet Mars. We have a Mars project now, okay? Still remember the Curiosity, which launched here, 2012. Okay, so the Curiosity is now on the Mars, so we are now doing the same things here. We try to calculate how many force we need to send this big uh, explorer to the Mars. Okay. Now, the space probe is midway between the two planets, so use the data given to calculate the gravitational force on the space probe due to the Earth, the gravitational force on the space probe due to Mars. Now, see the acceleration of the probe due to the gravitational force acting on it. Okay? Now, so question number 5. Oops, sorry. I need to call up a pen first. Okay? So, 5A. Okay? So straight away we know that we want to calculate the force between the probe and between the probe and the Earth. Okay, so we will have F equal to G m1 m2 over r squared. Okay, now I draw something over here. This is my Earth. Okay, so this is the Mars. Now this is my tiny small space probe. Okay, so it already now at the midway to the Mars. Okay, so it is the midway. Okay, this is the midway. So okay, so it's very simple. We are now not looking at the attraction because of the Mars. Okay, this is the Earth, this is the Mars. Okay, so where we are focused here is the attraction because of the Earth. So 6.67, so the standard one, 6.67 times 10 power negative 11. This is the gravitational constant. Now, time, the first thing is the Earth, the mass of the Earth, which is 6.0 times 10 power 24, which is given in the data, times the mass of the probe is 1,500 kilogram over the halfway distance between the Earth and Mars is given in the data, which is 3.9 times 10 power 10. Okay, don't forget to square it up, and you plug in everything in the calculator. You will get your answer as 4.74 times 10 power 4 Newton. Okay, sorry, it's negative 4 Newton. Okay, you can see now the force between the force that created between the Earth and the satellite probe is very very small, which is in the order of negative 4. Okay. Now part B. Part B requires to find what is the attraction force that caused by the Mars. So the first one is because of the because of the Earth. So I label it as F1. Okay, F1. Okay. Now I want to find the attraction force because of the Mars, which is given as F2. Okay, so F2, same thing. You go through everything. Okay, but the M1 will be because of the mass of the Mars. So I will go back and see what is the mass of the Mars. It's 6.4 times 10 power 23. So let's do it again. Okay, so this is the gravitational constant times 6.4 times 10 power 23. Okay, this is the mass of the Mars times now 1,800 divided by now the distance because it's the midway, so I will have something 3.9 times 10 power 10. So don't forget the square, and you will get your answer as 5.05 times 10 power negative 5 Newton. Now, don't forget that. So this the attraction force that due to the Mars is even smaller than the due to the Earth, because you have to understand that Mars has a smaller mass. Okay, Mars has a smaller mass. Now, in part C, the question wants to find what is the accelerations. Okay, what is the accelerations between of this space probe? Okay, so from you can see that there is a net force. Okay, there will be a net force between this F1 and F2. Now, from the point of view of the calculation of the data that you got, so very obvious that you know that F1 is larger than F2. Okay, so in this case we will have a net force pointing up to the Earth. Okay, so this is my Fn. Okay, so that we know that the acceleration is also pointing up to the Earth. Okay, so very simple, ma equal to F1 minus F2. So I will make use of a modulus to make sure that what I have is just a magnitude of the acceleration of the probe. I don't want to look through the. I don't want to have any interaction between the sign. So what I want is just a magnitude. Okay. So you just minus away, and finally, and divided by the mass of the space probe, you will get your acceleration is 2.4 times 10 power negative 7 meter square. Now it's still pointing to the Earth. Okay, still moving back to the Earth. Okay, so that's why it will require some extra force, okay, extra thrust to push it away from the attraction of the Earth, or you can say they push it away from the gravitational field of the Earth. Okay,